Here we have AP calculus AB problem. Okay, let's go with the question. Limit h approaches 0, 1 over h times the different integral 1 to 1 positive h square root of 3 positive x square dx. Okay, here a fraction 1 over h is multiplied by this stuff. Whenever we multiply a fraction by some stuff, the numerator of the fraction can be multiplied by the stuff we have over here. Then the given stuff will become, that is limit h approaches 0. When I multiply this 1 and this different integral, then I am getting integral 1 to 1 positive h square root of 3 positive x square times dx all divided by h. I just multiplied this different integral and this 1 and I have written the result in numerator. In denominator we have h. Okay, now what we can do is we can plug in the limit of h, that is 0 for h over here in this function. So when I do so, I am getting integral 1 to, okay, when I plug in h equals to 0 here, 1 plus 0, it's still 1 square root of 3 positive x square times dx divided by, now we can plug in the limit 0 for x h over here. So then we get 0 in denominator. Okay, now let's consider this definite integral. In this definite integral, the lower limit and upper limit are equal. In a definite integral, if the lower limit and upper limit are equal, then the value of the definite integral is 0 divided by 0. Okay, when I plug in the given limit 0 for h, so I am getting 0 over 0, which is called indeterminate form. Let me write the stuff over here. This is called indeterminate form. So when I evaluate the limit, if I get the indeterminate form as a result, that is 0 over 0, this is not a final answer. We'll be able to get a finite value as a result for the given limit. So to get a finite value as a result for the given limit, what we have to do is we have to do two things. One is we can do simplification of the given function if it is possible. Otherwise, we can use the second way, L'Hopital's rule. Okay, here I don't think there is a chance to simplify this function because it contains a different integral. So better we can use L'Hopital's rule. If I want to use L'Hopital's rule, what I have to do is I have to consider the step which comes right before where I have applied the limit for the given variable h. So this is a step I have applied the limit 0 for h over here and here. Okay, now we have to consider the previous step to use L'Hopital's rule. Okay, now let me write the stuff over here. I am going to use L'Hopital's rule. Let me write the stuff over here. L'Hopital's rule. Okay, what is L'Hopital's rule? Actually, L'Hopital's rule says you have to get the derivative of the numerator and derivative of the denominator separately. We should not use coefficient rule in this case because here we have a fraction. Whenever we have variable in both numerator and denominator of some stuff and I want to get derivative, usually we will be using coefficient rule. But when we use L'Hopital's rule, we should not use coefficient rule. We just have to get the stuff, derivative of the stuff in numerator and derivative of the stuff in denominator with respect to the variable for which we have the limit. Here we have the limit 0 for the variable h. So we have to get the derivative of this one and this one with respect to h. So let me write this stuff out here. That is limit h approaches 0. Now let me get the derivative of this numerator. That is d over dh of different integral 1 to 1 positive h square root of 3 positive x square times dx. And now let's get the derivative of the denominator h with respect to h. It will just become 1. Okay, now in my next step, we can ignore the denominator because whenever the denominator is 1, we don't consider, we can skip it. How do we have to get derivative of this definite integral over here with respect to h? For that, we have to use a fundamental theorem of calculus part 1. What is fundamental theorem of calculus part 1? Okay, now let's consider a definite integral where the lower limit is a constant a and the upper limit is the variable x. And let's consider a function f of t dt. Okay, now I want to get derivative of this different integral with respect to x. So why do I find derivative of this different integral with respect to x? Because in this different integral, the lower limit is a constant, the upper limit is a variable x. So since the upper limit of this integral is a variable x, so the result of this integration will be in terms of the variable x. So since the result of this different integral will be in terms of the variable x, we can find derivative of this different integral with respect to x. So let me write d of this stuff divided by dx. That is, I am trying to get derivative of this stuff with respect to x. So for that, there is a formula that is in this function. So we have to replace this variable t by the upper limit, that is the variable x. Then I am getting f of x. Further, we have to get a derivative of this upper limit, that is x prime. That is, we have to get derivative of this x with respect to x. Okay, now we have to take negative sign. So now in the same function f of t, we have to plug in the lower limit a for this t over here. Then we get f of a Further, we have to get derivative of this lower limit, that is a prime. Okay, now f of x, the derivative of this x with respect to x is just 1, negative. The derivative of the constant a is 0. 0 times f of a is 0. Then we get f of x times 1 is just f of x. We can ignore the 0. So the result of this derivative is f of x. So whatever stuff I have done over here, the same thing I can do over here to get derivative of this definite integral with respect to h. So here also we can consider the upper limit of this definite integral. So we have it in terms of the variable h. So the result of this integration will be in terms of the variable h. So we can find the derivative of this one with respect to h. Okay, now let me do it over here. Okay, so we get limit h approaches 0. Okay, now what we have done is actually instead of f of t, we have square root of 3 positive x square, and instead of t, we have the variable x. Okay, now what we have done is what we have done over here, we replace this t, the variable t, by the upper limit what we have over here. The same thing, we have to replace this variable x by the upper limit 1 plus h. Then I am getting square root of 3 positive 1 positive h the whole square. Okay, now I plugged in the upper limit for the variable over here. Further, I have to get derivative of this 1 plus h, like what I have done over here. That is 1 positive h prime. Now we have to take a negative sign in the same function. Now we have to plug in this lower limit 1 for x over here, like I plugged in a for t over here. Then I am getting square root of 3 positive 1 square. Further, I have to get derivative of this lower limit, like what I have done over here. That is a derivative of 1. And actually we have denominator 1 over here. We don't have to write the denominator 1 because the complete stuff is divided by 1. Still it is equal to the same stuff. Okay, now let's continue. We have a limit h approaches 0, square root of 3 positive 1 positive h whole square. Okay, what is the derivative of this 1 positive h? Actually we have to get derivative with respect to h over here. So the derivative of 1 is 0, and the derivative of this h is just 1. So finally the derivative of this 1 positive h is 0 positive 1. So the derivative of this 1 constant is 0. 0 multiplied by this stuff is also 0. Okay, let me continue over here. Then I'm getting limit h approaches 0, square root of, actually 0 positive 1 is just 1. When I multiply this stuff by 1, still I'm getting the same stuff. That is square root of 3 positive 1 positive h a whole square, and we can ignore this negative 0. So I just multiplied this 1 by this stuff. Okay, now what we can do is we can plug in the limit 0 for h over here, because that's all the simplification we can do after L'Hopital's rule. Okay, now let me plug in the limit, given limit for h over here. Then I'm getting 3 positive 1 plus, for h we can plug in 0, that is 1 positive 0 the whole square. Then I'm getting 3 positive 1 positive 0 is 1, 1 square is just 1. Then we get square root of 3 positive 1 is 4, square root of 4 equals to 2. Okay, now I have evaluated the value of the given limit, that is equal to 2. We find this to an answer choice C. The correct answer choice for this question is C.